The AI paradox isn't some kind of sci fi conceit to stop a Terminator from the future. It's the issue where perceived speed of automated coding clashes with measurable declines in software quality and productivity. In this week's deep dive, based on the Data Pro newsletter from May 6, we look at the ways sophisticated measurement frameworks can distinguish genuine efficiency from the illusion of progress. And don't forget to check out the audio podcast on this topic as well if it's something that interests you. It's available on all podcast platforms and it's a much deeper dive for data professionals.
Hey everyone, welcome to The Explainer. We are jumping right into one of the most hotly debated, kind of controversial topics in tech right now. We're taking a hard look at the empirical reality of AI coding assistants to see if they actually make engineering teams, especially data engineering teams, faster. Because let's be honest, the pitch we've all been sold is incredibly seductive, right? Hand your codebase over to an AI agent, sit back, and just watch production-ready software magically materialize at machine speed. But what is the data actually telling us? We've got a lot of ground to cover today. Think of this as our blueprint for debugging the current approach to AI. We'll start with the AI efficiency illusion, unmask the productivity paradox, and dig into architectural incoherence at scale. Then we'll tackle the verification bottleneck, compare agentic AI to real environments, and finally, look at the hidden human cost. All right, part one, the AI efficiency illusion, or the seductive pitch. To really set the stage here, we absolutely have to acknowledge the massive structural shift happening in software production. Look, according to Sonar's 2026 State of Code survey, 42% of all committed code is now AI-generated or AI-assisted. And even if you use a super strict definition of AI authorship, like in that recent ShiftMag study of over 4 million developers, you are still looking at 26.9%. So what does that mean? It means between a quarter and nearly half of all enterprise code running out in the wild right now was written at least in part by a machine. That is literally not a rounding error. And, there's a very real reason for this hyperfast adoption. AI tools save an average of 35% in drafting time. If you're a data engineer and you are staring down absolutely impossible delivery pressure for a massive new data pipeline, saving a third of your drafting time feels like a lifesaver. It is tangible relief. The sensation of working faster, it feels incredibly real. But here comes the twist. Section 2, Unmasking the Productivity Paradox. This is where we encounter a massive gap between what developers feel and what is actually happening. In 2025, Metra published a randomized controlled trial that is it's mind-blowing. Developers using AI assistants honestly believed they were working about 20% faster. But when researchers measured their actual productivity, making sure to control for task complexity and how mature the codebase was, the AI-assisted developers actually showed a net 19% slowdown compared to their unassisted peers working on the same complex systems. That is a massive 39 percentage point swing between perception and reality. So you're probably wondering, how on earth does an illusion that big even exist? Well, the researchers found that the work didn't vanish at all, it secretly shifted. The effort moved from the highly visible execution, physically typing out the code, to this highly cognitive, less visible verification and correction phase. The researchers put it perfectly. The effort feels lower even when it is not, because drafting feels like the hard part. You feel like you're absolutely flying, but really, you're just spending all that saved time untangling the AI's messy logic later on. Which brings us to Section 3, Architectural Incoherence at Scale, and the systemic decay it causes. Now, this decay is a very specific nightmare for systems architects and data engineers. It boils down to these two concepts. AI fundamentally optimizes for local correctness. Basically, it asks, does this specific little function do what it's supposed to do in total isolation? But live data pipelines require architectural coherence. That asks, does this function play nice within the messy, complicated, broader system? Because AI lacks that holistic, big picture view, individual components will pass local tests with flying colors, but then they trigger these catastrophic, cascading failures the second they hit integration boundaries. And we aren't just guessing here, we can measure this decay. Looking at 2025 data from GitClear and Veracode, it's wild. Code churn has doubled in AI-assisted environments. Duplicated blocks, up 8 times. Plus, AI code is introducing 1.57 times more security findings and 1.75 times more logic errors. Veracode even found that Java AI-generated code carries a security failure rate topping 70%. No way, right? These aren't just tiny edge case bugs anymore. We are piling up architectural incoherence at an industrial scale. Moving right along to Section 4, the verification bottleneck, or trust versus reality. Okay, so if the AI is making all these architectural mistakes, humans have to catch them, right? But check out this incredibly bizarre and honestly dangerous discrepancy. Only 4% of developers fully trust that AI-generated code is functionally correct. 4%! Yet, only 48% actually always verify AI code before committing it. Think about that. Thanks to deadline pressures, clunky workflows, and just how aggressively confident AI output looks, developers are systematically under-reviewing code that they themselves fundamentally distrust. And part of the reason they're skipping the review is that it's exhausting. 38% of developers report that reviewing AI-generated code is actually harder and takes way more effort than reviewing human-written code. All that time you save drafting? Poof, it gets completely swallowed by a grueling cycle of review, testing, and correction. Researchers have even started calling this new workflow, maybe with a little bit of wry humor, vibe then verify. So, when you mix lower trust, harder reviews, and this intense pressure to just ship the product, the operational impact hits hard. Pull requests per developer have jumped 20% with AI assistance. But wait for it. Incidents per pull request have jumped 23.5%. We are forcefully shoving significantly more code through the pipeline, but a much higher chunk of it is breaking things once it gets to the other side. All right, Section 5. Agentic AI versus real environments, the prototype mirage. Look, the tech industry isn't blind. They know these bottlenecks exist. And their big solution? Throw even more automation at the problem, using agentic architectures. And the promise of these multi-agent systems is genuinely awesome on paper. In controlled demos, these self-healing infrastructures are hitting 90% success rates on well-structured code. Observability layers are catching 96.4% of anomalies. But here's the massive catch. Data engineers do not live in sterile, perfectly controlled demo environments. They live in messy, complicated, tangled realities. Which perfectly explains why Gartner projects that by 2027, over 40% of agentic AI projects are going to be flat-out canceled due to reliability issues and poor risk controls. They call it the prototype mirage. An agentic system might look like absolute magic in a clean, structured demo, but it completely faceplants when it hits legacy codebases, ambiguous business logic, and the incredibly fragile interdependencies of live enterprise data pipelines. And that brings us to our final section, number 6. The hidden human cost, a systemic crisis. We've talked a lot about systems and code bases, but the most consequential takeaway sits right at the cross-section of economics and human psychology. Researchers call it the confidence-competence inversion. Get a load of this. 78% of junior developers trust AI output. Meanwhile, only 39% of senior devs do. Even worse, 60.2% of juniors will happily ship unreviewed AI code compared to just 25.8% of seniors. So the terrifying reality here is that the developers who are the least equipped to spot complex architectural errors are the exact same ones waving them right through into production. And this feeds into a much bigger structural nightmare. Since early 2024, junior developer job postings have plummeted by 40 to 50%. By automating away the friction of entry-level coding, the basic bug fixing, the routine reviews, the small failures, we are literally destroying the apprenticeship pipeline. We're ripping up the training ground we absolutely need to build the senior verifiers of tomorrow. And let's not forget the psychological toll this is taking right now. Researchers are documenting things like machine speed burnout and agent thrashing. Because we've removed the natural speed limit of typing out human code, developers are working faster, for longer hours, and spending their days frantically intervening in these totally unpredictable agentic loops. The mental overload of trying to manage these random stochastic failures is just completely burning people out. Okay, so what's the actual fix here? Well, the answer definitely isn't to just throw our computers out the window and abandon AI. The efficiency gains in drafting and scaffolding are absolutely real and valuable. But we have got to build a rigorous structural engineering framework for adopting it. We have to start treating AI code review as a completely distinct, specialized discipline. We need to measure actual outcome quality, like incident rates, instead of just cheering about the sheer volume of code output. We've got to separate the hype of shiny demos from the harsh reality of production systems. And above all else, we have to actively protect and rebuild that junior apprenticeship pipeline. It's not about running away from AI. It's about building the solid governance required to actually survive it. So I'll leave you with this final thought to chew on. Take a hard look at your own organization's measurement framework. Does it capture actual verifiable outcomes, or is it just capturing this highly seductive illusion of productivity? It's a fascinating paradox, and honestly, figuring out the answer to that question might just be the most absolutely crucial engineering task you face this entire year. Thanks so much for joining me for this explainer. Keep asking the hard questions, and hey, always keep looking at the data.
Thanks for checking this out today. Don't forget you can connect with other data professionals worldwide on our growing school platform. It's all linked in the description, so pop along, come in, have a chat, and check out the exclusive resources there for data professionals like you. And if you haven't done so already, please feel free to like, share, or subscribe to the channel.